ethical hacking and countermeasures. So not only will we teach you how to do the hackings, but hopefully we will teach you how to prevent the hackings, which is a more marketable skill. There's only so many pen testing jobs in the world. The cool thing about ethical hacking is to learn it, you also have to learn all the ancillary skills that go along with it. So programming and networking and systems and all that stuff in order to be any good at it. So for this chapter, we'll talk about what it is to hijack a session, what a session is, right? And then a little hair splitting about the difference between spoofing a session and hijacking a session. Talk about the different steps that are in there and the types that can happen. And then we'll talk about sequence number prediction. Did anybody have an opportunity to play with Fire Sheep or Droid Sheep when that was a thing? No, you puppies, you missed all the fun. There was a brief moment there where, because of crappy programming, sites like Facebook or LinkedIn, Facebook was probably the easiest target, used session cookies that were sent over the air, unencrypted. So if I'm at Starbucks with you and you log into Facebook and start doing stuff, I can grab the session cookie, and then, as far as Facebook's concerned, I'm you for the rest of the session, which leads to ugly posts, and then people are making fun of you because you posted that picture of yourself that you thought was private, and it just gets ugly. So Firesheep's an easy example of this. After we finish this up, we should be able to talk about what TCP/IP hijacking is. We've all heard of the Terminal Control Protocol, Internet Protocol. It's the thing that the internet runs on. Transmission Control Protocol, sorry, did I say terminal? Old school. We'll talk about some of the tools. One of the things that the EC Council does is kind of gives you the rogues gallery of crappy tools that hackers can use just by downloading them off the internet. And then talk about countermeasures for session hijacking. Like if programmers bothered to use TLS in their cookie sessions, Gesundheit, then you don't have to worry about people reading them. So we'll talk about the technologies, different spoofing methods. You will hear about the three-way TCP handshake over and over and over again in the course of studying any type of IT that involves a network. Once upon a time, programmers had to write their own networking protocols. You couldn't just say include TCP/IP.sys or TCP/IP.0 and have a networking stack at your disposal. Somebody actually had to write it. Talk about the tools that do that, and then the countermeasures that can be used to prevent that sort of thing. So what is session hijacking? You create a session in a web communication so that the server knows it's talking to you. So that Facebook knows Jamie logged in, or that LinkedIn knows that Seth logged in. During that session, we use that unique identifier, sometimes a nonce, a number used once, to create that session. That's one place we can get in between. The other place we can get in between is a TCP session. If there's a session going on, a TCP session, between two machines, a web browser and a web server, if a man in the middle can get in there and hijack that, they can take over one of those two positions. So I can pretend to be the client, or I could pretend to be the server in that case. I could desync it, start sending my own packets, and then all hell breaks loose. So hopefully, at some point in your career in computer science or computer applications, you've run across the old TCP/IP stack before. It's analogous to the OSI model, except it's the one we really use, and the OSI model is the one we really talk about in computer classes. But basically, you have the physical connection on the bottom. Above that is the network connection above that. And usually, you're thinking network protocols on that. Above that is the transport layer, which is generally the ports you're talking about. So if the network is my IP address, the session layer is the port on my IP address. What port do web servers generally use? 80 for regular web servers, and for an encrypted one? 443 or 8080 is an alternate that gets used a lot, or 8000 gets used a lot. And then above that transport layer is the application layer, so the actual web server itself, the program running on a server somewhere, accepting connections, spitting out web pages, doing all that stuff. There is the TCP/IP stack. Unfortunately for us, or fortunately, depending on which side of the coin you want to look at, the IP version 4 stack was developed in a kinder, gentler age of the internet. So it didn't address any of the big, important issues that face us now with networking: authentication, so knowing who I'm talking to; integrity, knowing that the communication is actually as intended; or the privacy, knowing that only you and I can read our private communication, right? None of that was taken into consideration when we built IPv4, because people were just happy to have anything at all working. They're like, yay, I can send a packet to another computer. So session hijacking is taking over one of those active sessions. Spoofing is just pretending to be something else. So spoofing a computer to pretend to be that computer. That way you can get access to a target machine or a target server. They're different. Spoofing is one thing. Hijacking is another. You can blind hijack, where, man, I think I heard about a McDonald's hack that was something like this. Security Now is talking about a app on the McDonald's website that used a sequence number that you could just guess at to create a connection that appeared to be from an actual user. In fact, I think Steve Gibson was talking about how his web store used to let you put in a order number, and then if you blew it, well, it's kind of different. You would get the order number back and it would show it in the form. But that let an attacker put data into a web page, which is never good. So anyway, a blind spoof is where you don't necessarily have knowledge of what's going on. There's a lot of ways to spoof an IP session. So you've got to have a machine to which you have root. So in this class, it'll be a virtual machine that you own. And if you've got access to the low-level network drivers, which you should have on a machine that you're using for your ethical hacking purposes, then you can send whatever stupid packet you want to send to the internet. And it can guess sequences, or it can try and take advantages of vulnerabilities or whatever. If the networking provider is worth their salt, source routing should not work. There is specifications in IPv4 that probably weren't thought of in a security context that say you're allowed to specify the route that a packet should take back to me. So when I send a packet out to Google, Google sends a packet to my computer's address and it comes back. What source routing enables me to do is tell Google how that packet should come back. Now, that's a bad idea, because one of the things I can do if I'm doing source routing is I can pretend to be that which I am not. So if I can specify a source route, I can say, so I'm pretending to be Dominic's computer, and I send out a packet that says Dominic's computer's address on it, but I say, hey, make sure you use source routing so that you go from Google to Drew's computer, then to Dominic. For sure, it's going to get to Dominic eventually, I promise. No problem here. I am not going to merely read his email and then send the response back without ever sending it to him. Just make sure you send that packet back to me and it'll be fine.
I don't send any emails, so you're going to be disappointed.
Aw. I'm sending a lot of emails right now as a part of a little research project. I will share that with you later. So session hijacking is a little more difficult than that. So source routing, like, good routers reject that. A well-configured network will say, that's dumb. I'm not going to let you do that, because obviously you could be trying to man in the middle poor Dominic here, even if he doesn't send any emails.
That's pretty much done away with.
We would like to think that. So your mileage may vary. That's an interesting thing to research. So you can actually send packets to different networks and see if they come back the way you tell them to come back, or if they come back direct. So it's one of those things, like source routing should be a thing everywhere, and egress filtering should be everywhere. And egress filtering is on the way out of a network, a responsible network provider who's got packets leaving their network. Egressing is just a fancy word for leaving the network. So if I've got packets leaving the network that don't come from that network, or that allege not to come from that network. So if I send a packet out of my network that says it came from Dominic's IP address because I'm totally going to own his email, a good internet service provider will say, whoa, 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 buckaroo, we're not sending that packet on. That didn't come from here. No, no, no. And so egress filtering is a network configuration that will just throw that away. They'll say, psh, I'm only sending traffic for Drew. I'm not sending traffic for Dominic. And that's another thing that a decent internet service provider just hits that switch and a million problems on the internet go away. But it's not hit as often as we would like. So session hijacking is like a little more difficult than that, although it's not as dependent on crappy networks. So instead of sending, so like if IP spoofing is the example here, I use Dominic's IP address to send a packet. IP spoofing is pretty straightforward. Session hijacking, instead of inserting myself into a network conversation, I insert myself into a session conversation between a client and a server. So Dominic's already logged into Facebook. And we're sitting at the same coffee shop. It is a little bit more challenging nowadays to grab that session cookie that Facebook gave to him so Facebook knows that it's his authentication than it would be to just pretend to be his computer. The way to take advantage of this is Dominic sits down at the coffee shop, logs into Facebook. I see that he's logged into Facebook. I grab that session cookie. I start using that session cookie for my conversation with Facebook. And then I do something nefarious to knock him off the network. So all of a sudden his Wi-Fi breaks or something starts happening weird and he falls off the network and he's like, this coffee shop sucks. They've got really lousy Wi-Fi. And he walks off, pissed off, splashes his coffee in the face of the barista on his way out and says, I'm never coming to this place again. You and your trashy Wi-Fi. Meanwhile, I sit at my desk snickering because I've obviously got a hoodie on, chuckling to myself as I finish logging him into all of the Facebook furry groups I can get my hands on.
Joke's on you,
So beware, another like low-tech session hijacking problem that I have seen actually happen in this classroom is if you start a session with, say, Blackboard and you're logged into the computer, and then you leave and you don't come back, that session is sitting there, and to hijack that session, all some other student has to do is go, Not that that's ever happened to anybody in this room before, but it is conceivable that somebody could hijack your session like that. And then you've actually done all the work. You started the session, you left it open, and then you walked away without closing the session.
Oops.
You did the session hijacking for yourself. Do you start the email to the president and leave it waiting for the send button? Subject, take this job and shove it. Body. I got your TPS report right here. So IP address spoofing only works if a system is using IP addresses to figure out authentication. Hopefully, systems have mechanisms beyond just, okay, that's Drew's IP address, so he's good. Non-encrypted TCP communications, if you're gonna interrupt one of these things, TCP uses sequence numbers, and hopefully not predictable sequence numbers, but oftentimes predictable sequence numbers. So if you see them, a TCP session goes, we do this handshake thing, and then this is packet 1. I received packet 1. Here's packet 2. Received packet 2. And then they make a window, and then they say, I'm going to wait to acknowledge this until we get to packet 50. So there's this sequence of numbers. Well, if I can jump in the middle of that sequence of numbers and predict the next sequence number, then I can say, oh, wait a minute. This is sequence number 75. Oh, OK. And I can take that over. Now, I'll need to, if it's a local area network, I'll need to take over the MAC address, the media access control address, the address burned into the network card itself, or supposedly burned into the network card itself, or the IP address, so that you get the return of that communication. So that's this problem you can solve when hacking with source routing. You can tell the communication to come back through you. If source routing doesn't exist, and the communication goes back to a particular IP address, then you can't hear it. So that's a problem. And if it's a local area network and it doesn't go back to your MAC address and you can't hear all the traffic on the network, you can't hear that either. And that's a problem.
Can I ask a question?
Be my guest, James. What's your question?
If the TCP sequence numbers are randomized, which I assume they do to prevent prediction, how does the router know?
The router doesn't care. The routers, that's not its problem. The client and the server, they're the ones who check that.
How do they know if the sequence?
Well, they can't be random. They have to be a sequence of some sort. So you can change the way you, get to that sequence. But, so they have to be predictable-ish. One of the ways you can identify operating systems, so like that's not in the standard. So it's up to the software developer who writes, you know, TCP/IP.sys for Microsoft to determine how it is they're going to play that game. So for a while, it was just like, let's start at 1 and add 1.
But it's still sequential. I mean, it might be like, I have 1,000, now I have 2,000.
Right. Yep. It's got to be sequential. It's got to be like, here's packet 1, here's packet 2, here's packet 3. But where you start that, you have some control over. So how that works, tracking a connection. Somehow, if you're going to hijack a TCP/IP session, you need to get on the network with them. So you need a sniffer somewhere between the victim and the host. And then you use something like Nmap or a tool like that to learn about the host. Next, you kick the session apart. So you change the sequence number, change the acknowledgement number of the server, and the client on the other end gets confused. He says, that's not the number I was expecting, because you sent him a packet from the server's IP address with the wrong number, and now the poor client doesn't know what's happening. Then, once you've screwed up that session, now you can take over. Now you can start sending a packet in as if you were that person. And if all of this sounds horribly complicated, fear not, somebody's already done all the coding. There are tools that do this process for you. You don't have to worry about coming up with something to desynchronize TCP/IP sequencing. Somebody's already written the code to make this happen. So here's how that might look. Graciously, we don't have any pictures of people in hoodies or with like zeros and ones shooting off the screen at their faces. But I can't promise that that's going to be that way for the rest of the semester. So let me get my laser pointer out. So here we have a server somewhere, and this poor guy is obviously an ops person. Be careful with them. They tend to be grouchy. They don't always love their job. Sometimes they have to work 100 hours in a week. So victim John here, and usually it's Alice and Bob who are having conversations, and then like Carol gets involved. But so here's John. He logs in with his credentials. Mr. Attacker down here notices that that's going on, spoofs the IP address, takes over the session, and the next thing you know, the attacker is pretending to be John with all of the rights and privileges that John just logged in with. So maybe it's his Facebook and they're just having a good time of it, or maybe it's his bank account and he's going to lose hundreds of thousands of dollars. But John, with all that money, should know better than to log into his bank account. So that's TCP/IP. So that's using the network against an attacker. So because we didn't think about security when we wrote the protocol and the stuff for IPv4, that's a problem. Session hijacking is a layer above that. So that's how you do it on the network layer. This is sort of how you do it on the application layer. You can do it actively or passively. Actively, you knock over an existing session. So you kick somebody off the network, like that example I talked about with poor Dominic in the coffee house. Or passively, you just kind of sit around and sniff. So I think the deal with the McDonald's thing was the password was stored on a cookie on the user's computer. And because of a poor implementation, you could actually expose that. I think the deal was that there was one salt and one key used for everybody who logged into McDonald's, period. So once you had the salt and the key figured out, you could look at anybody's password in plain text on their computer. So that's passive, right? I don't have to actually get involved in breaking network connections or anything. I just have to look at a file on a computer and unencrypt it. If you have raw access to a network, just sniffing user IDs and passwords is the easy way to do it. You can use a tool like dsniff, and it will tell you, hey, I just saw an FTP login, and the user was Steve, and the password was nobody will ever guess my password. Hey, I saw a Telnet login, and the password was Telnet user, and the password was nobody will ever guess my Telnet password. So super simple, but mostly we've moved on past protocols like FTP and Telnet because we know this, right? We know that those communications are not encrypted, so therefore they're not secure. If you can do it on the network level, you can bust in to all sorts of things. You can break a server's TCP UDP session, which if you think back to maybe something you read about networking once upon a time, TCP is the stateful, connection-oriented way you can talk IP, and it establishes connections with this freaky three-way handshake thing, and then it starts a sequence number. UDP's sort of just like spraying a fire hose at a client. You just start sending packets and you hope it gets it. Sort of like my lectures sometimes. I just start talking and I pray to God somebody's listening. But I guess that means that receipt of information is not required because you can always look it up in the book anyway. All right, so including the following, you can do TCP IP hijacking, you can spoof an IP address if they allow source routing, right? You can pretend to be Dominic's IP address, and if it allows source routing, you can make sure it routes through me first, and then it got to Dominic for seriously. Yes, and more ingenious ways, you can use reset packets to get in there. You can do it blind, where you're just going to guess at what's going on. If you get a packet sniffer in between, you can sniff the incoming traffic and spoof it that way. You can also spoof UDP. So if you, UDP is used a lot in games, right? So if you can predict how the game sends, player target location information. So the CSGO server sends the location of all the players on the map. If you can interrupt that, if you can hijack that transmission, you can desync a client, you can get into all sorts of nastiness, which is why it's fun to put your multiplayer games through Burp Suite. All right, so I kind of pussyfooted around the three-way handshake here, but if you spend any time in networking or programming that involves the network, you should understand how this works. Once upon a time, like I said, people used to have to write their own network stack every time they wrote a protocol. But since we kind of agreed that TCP IP works good enough, everybody should use this and we should know how it works. So this three-way handshake starts the connection. We exchange all of the various parameters we need to know about like how fast the network is between us and how big the window size should be for packets. We started off with an initial sequence number and set the SYN, let's synchronize flag. Server gets that, says, what up, client? Here's the sequence number, and here's my own initial sequence number, and here's my SYN flag. And the client says, hey, I got your synchronization message. I will acknowledge that. I will increment your number, so here's where we can't really play with it much because it's built into TCP IP. And I will send the acknowledgement back. I received packet number 1. So that's the three-way handshake in a nutshell. Oops. Session hijacking in a nutshell. Get between victim and target. So ideally, sniff the network. Watch the traffic. See if there's some kind of sequence number. Break the connection to the victim's machine. Dominic storms out of the coffee house. Take over the session. Subscribe to furry Facebook web pages. Start injecting packets to the server. Just that easy. If, some more TCP IP, if you get a packet with the reset flag, that says, we're done talking. The host will consider that the end of the conversation. So it says, oh, okay, that's over. So if the client gets that reset flag, it's like, oh, I guess that session's done. And then you can carry on the remainder of the conversation with the server. If it gets a fin flag, it enters a closed wait state. And do this for me real quick on the computer you're sitting in front of. Start up command and do a netstat. I think it's AN. Yeah, netstat-AN, and pipe it to more. So that command right there. Netstat space alpha Nancy. What is the numeric for N? Okay. I don't think so. And then pipe that to more. Pipe symbol's the one above the slash, more. And here you will see those states listed for all the current active TCP IP connections on your system. So I've got a bunch talking to what's port 443? Transport layer security or a secure web connection. November, thank you. Number was wrong, Nancy was wrong. The people who play Battletech, MechWarrior Online, they are very particular about you using the appropriate numerics when you start calling out targets. Oh no, well your reticle has an alpha numeric indicator for them. So like, bring fire on Zulu 7. Because it's on the map, it says Z7. But if you were to say Zebra 7, like there's no freaking zebras here. I always mix up, mix up hotel and helo. Because the proper mnemonic is hotel, but at some point somebody said helo to me and it stuck. So if I say, there's no freaking helicopters in this game. So you will see, all right, back to this. You will see closed wait, you will see established for established TCP connections, and listening for things that are waiting to pick up the phone on these TCP IP sessions. All right, and I've even got some IPv6 UDP stuff going on down at the bottom. Believe it or not, those are IP addresses for those of you who have never been exposed to the wonderful worlds of the next generation of IP protocol. That's the number you're going to have to type into your computer when you set up your IP address. So if you would, grab a screenshot of you doing that and throw it into a Word document. We'll upload it to the discussion later. So those are the different states. So if we're going to talk, we need an IP address, right? And on netstat, that's that first one there. That's that second one there. So my IP address, here's one that's 192.168.253.1. You need a port number. So in the case of TLS communication or HTTPS communication, that's going to be 443. And I had some of those around here somewhere. Yep, all of these for the most part. And you need a sequence number, which we don't display unless we do, I don't know if I have T-Shark installed here. Let's see.
Could you describe the difference between closed wait and just closed?
I think closed wait will restart, potentially. And closed is you shutting down the connection and turning off.
So the closed wait, you don't have to do the issue.
I think that's how that works. Google me and double check. Because that's a question I should feel more confident in my answer about, to be honest with you. All right, so here's our session hijacking. We've got a synchronization from Bob. Finally, Bob and Alice get into the picture. He sends over sequence 4,000, and the server sends back sequence 7,000 and acknowledges 4,000 by incrementing the number 1. So the server sends back 4,001. Bob acknowledges sequence 7001, right? I got number 7,000 from you, and I set that back. They have made these more random as time has gone on, and they've realized that it's a security flaw, you know, to just be able to start a conversation at 5,001 and know what's going on. And now that's a way you can tell which operating system you're dealing with, because different operating systems handle it differently. So SYN, SYNAC, ACK, and you're off to the races. So every byte that goes over there has a sequence number. The receiver responds with the same sequence number. Different connections start with different numbers so that we can't just jump in the middle of these things. There are 32 bits in them, the same length as an IP address, 4 billion possible combinations. So we've allocated 32 bits of a TCP IP communication to this whole sequencing thing. Now, if you think about it, that means that's 32 bits that can't be used to send data. So it's sort of why TCP IP is a little wasteful in terms of communications. And Google's actually working on a faster way for web servers to send data that uses UDP and its own sequencing stuff to eliminate that. It's built into Chrome right now. And Apache and Nginx and a bunch of other systems already support it. So if you're the kind of person who keeps an eye on their internet traffic or routes things through Burp or looks at the processes going on their network, you might start to see, I think it's called QIK or something like that. Somebody Google that one up for me. But it's a new way to do this that will actually throw a monkey wrench in some of the stuff we try to do here. So TCP/IP connections usually start with a random number generated. But there's only so much in there. Relying on those are vulnerable to statistical attack, meaning it's only a mostly random number. It's not a real random number. They're hard to do, real random numbers. Pseudo-random numbers are not random. So in theory, masterminds can come up with ways to predict those random numbers. And then if there's a sequence, there is a receive window that says, don't get back to me until we get to packet number whatever, because I know that's going to be pretty okay. If the sequence number is inside that window, an attacker could put something in there, change the web address that was coming back on a link, or any other sort of nefarious business you can get up to when you can be in between the client and the server. If sequences are predictable, that's bad. If the attacker gets to the service first and starts the whole ball rolling, they win. If there's no SYNAC that I can see, but I can guess what the SYNAC would be, because I know that all Microsoft Windows NT servers start the acknowledgement process with number 1000, I can jump the gun and get in there. If you're using the IP address as something that is secure, so if you're pretending like IP addresses are good enough for authentication, then I can break into that conversation, because I can say that I'm whatever IP address I want to say that I am. So not a way to develop an application to test for security. So to do that TCP hijacking thing, to get in the middle of that, you sniff the communication, figure out what that initial number was, and then using it, you can start sending spoofed packets to the victim, to the host machine that you're trying to communicate with, to the web server or whatever. And then so if I'm hijacking your Facebook session again, Facebook will start talking to me, assuming that that packet came from you or was intended for Dominic.
Oh, sure.
Ooh, yeah. If you're playing along at home, it's time for the first ethical hacking guy using a computer with a ski mask clip art of the year. So here's our host, our victim, and our attacker. The step one is our victim starts talking to, that guy looks like he works at a bank, right? So he starts logging into, fifththird.com. The host responds back, hey, here's your banking statement. And the evil attacker, notice he's guessed the sequence number and jumps on in with a length smaller than the actual length, but we're good from there. So now the attacker is pretending to be the legitimate user, the victim, and we know the attacker is a bad guy because he uses a ski mask when he goes to log into his computer, like I imagine most of you do. It gets cold. So that source routing thing, if your network is dumb enough to let me do it, I can say, I'm here, but I'm talking for Dominic. I send you his IP address and it comes back through me. The reset hijacking is using the reset packet to reset the connection. If I use an accurate part of the TCP/IP sequence, I can get you to hang up the phone, basically, with the server, thinking that the server wants to hang up, but it's really me continuing that conversation. So again, drink. In this case, the attacker just sends the reset packet to the unsuspecting web developer. So you could be a web developer. The connection resets, and now I can continue on your conversation with the server. If you've got a packet sniffer, even if you don't, you can perform man-in-the-middle attacks, so you can listen to the client-server communication and then just sort of insert your communications as if you were either one of those parties, which is a problem. And you can do that either by using ICMP packets, so ping or traceroute packets to redirect traffic through me, the attacker. Since UDP doesn't care about sequences or any of that stuff, it's just this fire hose of data. There's no sequencing, there's no synchronizing, there's no handshaking. It's just like, here's a packet, this is packet number 1. The rest are coming. So how you reply is up to you. And then jumping up to the application level, if there's some kind of session identifier number that the programmer has used to write the application, I can use that to get control over that session and create a new session. And there's all kinds of ways I can get up to mischief with that sort of thing. If there's a session ID running and I can figure out what they are, I can get into that. If I can sniff traffic coming off of the server and read it, I can come up with, hey, I can take over this session. If I've had a chance to look at the application, for example, if I install Burp Suite on my system and I've watched how the server communicates with me and I know it keeps sending out this session ID and it seems to be in a particular order, I can just throw brute force at it and try every possible session ID that mostly looks like the one I got until something I want to have happen happens. And then if I can misdirect trust, if I can make them think that I am an actual client, they send me a session ID. If I pretend to be his IP address, for example, or I pull the session ID out of plain text web traffic, I'm in like Flynn. So here are some tools you might want to download and experiment with. Like I said, one of the purposes of these classes is to just let you be aware of what the hackers in the world have at their disposal, and all of these tools do pretty much what they say they would. Pharos has got a tool that will do this whole HTTP session hijacking thing for you. DNS hijacker will hijack the domain name resolution protocol to tell you that google.com is actually Drew's IP address. That one looks like this. IP Watcher will keep an eye on IP addresses and mess with those. Remote TCP IP utility will get in the middle. And again, these are all Windows tools. There are analogous tools on Linux. We recommend everybody who's going to take this class download and install Kali as their attack box, so you'll have access to a bunch of good free tools. We'll talk about that later. So why do we care? What's this hijacking thing? So what if Dominic is now signed up to a bunch of Facebook groups he doesn't really care about? What's the big deal? Well, Facebook's only the tip of the iceberg, so I can do his bank, I can do his student login maybe, his Ameritrade account where he's got millions of dollars invested.
I wish.
Oh, stick with me, kid, we'll find some Ameritrade accounts. But all of that sort of thing. And there's a bunch of sort of halfway countermeasures that get us most of the way there. A one-time password's a good deal, but not invulnerable. Kerberos is a type of authentication system that Windows makes use of. Source address filtering router, again, helps make sure that only traffic that comes from us is leaving the network and not traffic coming from some other network. And source address controlled proxies, meaning proxies that don't let you play those games either, are good. So how can an application developer or a network administrator prevent against these sorts of things? To prevent session hijacking? You can fight brute forcing anything by limiting the number of attempts. Right? Your password on your computer is protected against brute forcing by limiting the number of times you can try and log in to 5 before it makes you wait a half hour. If that half hour thing doesn't exist, I can just turn on a computer to try and log in every second with A, B, C, all the way to Z, 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 and then it's just a matter of time before I get in. So if you limit the number of connections that your application allows from a particular IP address during a particular time frame, you can prevent that. Using encryption is really our only hope for salvation in this world. Encryption will prevent any of that man-in-the-middle falderall, and it's what everybody should be doing all the time. The Electronic Freedom Foundation has a great encrypt everything campaign going on right now. I'm all for it. Minimize remote access where possible. So if people don't need to be able to remotely get to servers, don't let them. And if they must, make them jump through a lot of hoops, hopefully hoops involving two-factor authentication before they get back to it. Use a secure protocol. So never, ever, ever should anybody in this room write a program that uses like FTP or Telnet or rsync or any of the old original, back in the day when my grandfather first invented the internet kind of protocols. Those are all garbage. You need to be using something that encrypts, something that keeps things secure. And then, and this is the hard one, I know some very smart, well-educated people who are dedicating their lives to trying to figure out how to do this. Educate the users. good luck with that. But you have to teach people what to do. You could use IPsec if you've got a network that will support it. There's a bunch of stuff that sits on top of IP that constitutes IPsec. So it was like, hey, we realized we didn't do this very secure. Let's add all these other protocols on top of it to make it secure. And it's pretty good. I mean, it does what it's supposed to do. So it supports network level authentication. So you can confirm that authentication piece that's missing for most of TCP/IP. You can confirm that it's your computer talking to our default gateway. And it's not your computer talking to Rosema being a jerk again and spoofing the default gateway, who's then in turn talking to the default gateway. Can figure out where the data came from, can make sure that data is integral. So when my spoofed man-in-the-middle attack on Elliot gets to the default gateway will say, no, the checksum does not line up. The crypto is wrong. You fail. Confidentiality is provided because it's encrypted, so I can't read it because I don't have the corresponding keys. And it's, IPsec provides forward security, so the keys change over time, so you couldn't just replay Elliot's login to the server. So I couldn't just record Elliot sitting down at his computer and logging in and then play those packets back to the server at a later date because they're protected from replay. So that's session hijacking. An attacker takes some kind of legitimate user's access, authenticates, takes over the session, and gets up to no good. Erases his bank account, cancels his home mortgage, emails his boss that he's quitting, posts into the discussion forum that, what was it? Something about furries? No, the one that was actually posted in there. I forget, it was something about bloodborne pathogens or something. It was creepy. In a spoofing attack, the attacker pretends to be another user. I'm spoofing that I am Dominic's computer when he goes to log into Facebook. Session hijacking, depending, in theory is fairly difficult. If the application is written in a good fashion, it should be difficult. But if the attacker has control of any of the environment, for example, if they can listen to traffic, which happens to be true on a lot of wireless networks, in particular in a lot of public wireless networks, then you're in trouble. And that's what got Facebook in so much trouble with Droid Sheep, Fire Sheep a ways back. As long as you could listen to that session, you could grab that cookie, you could hijack their session and become them on that service. And that's bad. I think my, the guy who taught the web application hacking class this over break, he got owned like that when apparently Gmail had a vulnerability similar to that, maybe a long while ago, 6-7 years, which is forever in IT. And then those attacks can be passive or active, right? I can be sitting there listening, writing things down, or I can be getting involved in the conversation actively. It can happen on the network level, intercepting data from a client and server. It can happen up the network in TCP/IP, where I spoof packets to take over a connection. In UDP, since I don't have to worry about that three-way handshake, sequence number, folderol, you can just start sending in packets and screw things up, which is why a lot of people mess up game servers and piss everybody on the internet off, make everybody sad. If you get to the application level, you figure out how to get a session ID like Droid Sheep or Fire Sheep to take over a session and maybe create new sessions down the road if you get to like a password or that kind of thing. You don't have to be a programming super genius to pull this off. There are tools out there for Windows even that do all this mess for you. And it's a problem, so you need to have good countermeasures. They're not going to be foolproof or anything, but you need to have good ones. It's chapter 1 right there. Hijacking sessions.